Hi, students, and welcome to today's lesson. I'm Mrs. Quarterman. Today, we will explore the question, why is the moon visible at different times of day? Are you ready? Grab your pencil and your science journal, and let's get started. Oh, look, here is a photograph of the moon. But wait a minute. Does the moon look different from photographs of the moon that we have seen so far? Before we explore this question, let's review what we already know about the moon. Last time we developed a model showing the location of the moon. Based on our observations of the moon at night, we place the moon on the side of the Earth that is facing away from the sun to show that the moon appears in the sky during the nighttime. Our anchor model also shows the moon appearing in the sky at night. We need to add to our new knowledge about the moon to our anchor chart. We have already learned so much about gravity and the sun. Now let's add a moon section to our chart. Just like we did in our other sections, we will add our new knowledge from both the Earth perspective and the space perspective. So what can we add under the Earth perspective? How about the moon appears to move from east to west across the sky? Now let's think about the space perspective. What have we learned so far? We know the moon appears to move throughout a day because Earth rotates counterclockwise on its axis once per day. Great work! One of your tasks today will be to update the anchor chart, but I think we'll have even more to learn about the moon. Now let's look at this photograph of the moon again. What do you notice? Do you notice that this picture was taken during the daytime? So do I. The moon is also a different shape than the moon in our model. How does this photograph of the moon compare to our current model? Well, the photograph shows the moon visible during daytime, but our model shows the moon on the nighttime side of Earth. As you look at this photograph and think about our model, what questions do you have about the moon? I wonder, why is the moon visible at different times of day? We will explore this question in today's lesson. We can start by looking at our space view model again. Why is the sun visible only during daytime, but the moon can be visible during nighttime or daytime? Well, we know that night occurs on the part of Earth that is facing away from the sun, so the sun can never be seen at night. But what about the moon? How can the moon be visible during nighttime or daytime? I wonder if the moon is sometimes on the nighttime side of Earth and sometimes on the daytime side of Earth. How can we position the sun, Earth, and moon so that the moon is visible during daytime? Look at this model of the Earth, Sun, Moon system. How do we change the model? The moon is now between the sun and Earth. Now the moon can be seen in the sky from the daytime side of Earth. Do you think both of our models accurately represent the Earth, Sun, Moon system? Show me a thumbs up if you said yes. Show me a thumbs down if you said no. Did you give a thumbs up? Thumbs up is correct. Let's talk about why both models accurately represent the Earth, Sun, Moon system. We have evidence that the moon is visible during nighttime and daytime, and both models show how the moon can be seen at different times of the day. But now I have even more questions. What questions do you have about these two models? Maybe you're wondering, how can there be two models? Or does the moon move around Earth? Let's look at our space view model again to see if we can explain how it is possible for the moon to be in different locations around Earth. So how did we update our model of the Earth, Sun, Moon system? The moon in our model is now moving around the Earth. This movement makes it visible during both daytime and nighttime. I wonder, how can we investigate how the moon moves in space? Maybe we could start by observing the sky to see if the moon is visible during daytime or nighttime over a period of several days. Then we could look for patterns. What data could we use to determine when the moon is visible? Do you think we could look at what times of day the moon is visible in the sky? I think that's a great idea. I've already collected some moonrise and moonset data from Washington, D.C. for us to analyze. We can use the data to gather evidence of when the moon is visible on different days. Let's analyze 2 days together, January 1st and 2nd, 2019. We have a 24-hour timeline for each day. Let's think of the timelines as a number line. We'll place an up arrow at the moonrise time and a down arrow at the moonset time. We will start with January 1st. Moonrise time is 3:09 a.m. We will round our time to the nearest half hour, so let's add an up arrow to mark 3 a.m. on the timeline for January 1st. Moonset time is 2:03 p.m., so we will add an arrow to mark 2 p.m. Now let's look at January 2nd, 2019. Moonrise time is at 4:10 a.m., so where should we add the up arrow? The closest half hour is 4 a.m., so we will add an up arrow to mark 4 a.m. on the timeline. And now let's look at moonset time. The moonset time for January 2nd is 2:39 p.m., so we will add the down arrow to 2:30 p.m. since that is the closest half hour. Look closely at our two timelines. How can we determine the length of time that the moon is visible in the sky on each date? I know. We can count the time between moonrise and moonset. Each box represents 1 hour, so we can count the number of boxes between the up arrow and the down arrow to determine how many hours are between moonrise and moonset. Let's count the boxes for January 1st. I count 11 boxes. So the moon is visible for 11 hours between moonrise and moonset. Now let's look at January 2nd. Count the boxes. How many boxes did you count? I counted 10.5 boxes. So the moon is visible for 10.5 hours between moonrise and moonset on January 2nd. How can we show the total length of time the moon is visible on the timelines? I know. Let's color in the space between the moonrise and moonset times on both days. Great work. We have been trying to determine when the moon is visible in the sky. We looked at some data, but in order to notice patterns, I think we need to analyze more data. Let's add the moonrise and moonset times for January 3rd, January 4th, January 5th, January 6th, and January 7th. Based on this data table, at what times of the day is the moon visible in this location? I think the moon is visible between the early morning and early afternoon for the first few days of January. What trends do you observe in this data set? I notice that the moon is visible for about 10 to 11 hours each day, and the moonrise and moonset times get about 30 minutes to 1 hour later each day. Using this data table, can you predict the visibility of the moon on January 8th? One of your tasks for today will be to answer this question and explain how you made your prediction. After observing the trends in this data, can you predict when the moon would no longer be visible during daytime? Do you think that would happen later in January? I think it might, but I also think we would need to look at moonrise and moonset data for the rest of January to answer this question. Do you agree? In our next lesson, we will answer this question and look at additional data for January. Let's review your tasks for today. First, fill in the blanks to update the anchor chart. Second, predict the visibility of the moon on January 8th and explain your prediction.